All right, today we're going to dive into a choice in system design that can literally make or break your application's ability to grow. The choice between stateless and stateful services. So picture this. Your app gets a massive, totally unexpected surge in traffic. Thousands of new users are flooding in every single second. I mean, this is the dream, right? But is your system actually ready for that dream to come true?
Because the sad truth is, for a lot of applications, this dream scenario turns into a total nightmare. The servers get overloaded, everything slows to a crawl, and then the whole system just crashes, locking out every single one of those potential new users.
So what's the difference? What's the secret sauce that lets some systems handle that explosion of traffic without breaking a sweat, while others just completely fall apart?
It really all boils down to this one single critical idea: state. How your application remembers, or maybe more importantly, forgets information about its users between clicks is the absolute key to unlocking real, massive scale.
Okay, so let's get into it. We're going to define our two main players here: stateful and stateless architectures. And trust me, they're two totally different ways of looking at the world.
First up, we've got stateful. Think of a stateful server like a personal concierge at a fancy hotel. They know you. They remember your name, what you like, the whole history of your conversation. So when you ask for something new, they've got all that context ready to go. It makes things feel really smooth. Now, on the flip side, you've got stateless. A stateless server is more like calling a new front desk clerk for every single question you have. They have zero memory of who you are or what you talked about before. Every time you connect, you have to start from scratch. Now, that might sound inefficient, but as you're about to see, this forgetfulness is its greatest strength.
So when you put them head-to-head, how do they stack up? Well, this table lays it all out pretty clearly. You can see right away that stateless just crushes it when it comes to scalability and fault tolerance. Stateful systems, yeah, they might seem simpler for some things, but they get super complex when it's time to grow. And let me tell you, debugging becomes a whole different beast. Trying to fix a bug might mean hunting for one specific server that's holding bad data. It's a real needle in a haystack problem.
All right, let's really zero in on the biggest, most important difference between these two. The thing that really matters when you get that massive traffic spike: scalability. With stateless services, scaling is, well, it's just beautifully simple. Since no server is holding on to any user-specific data, they're all basically just clones of each other. They're interchangeable. Need to handle more traffic? You just spin up more servers. A load balancer can send any request to any server, and it all just works.
Now, trying to scale a stateful service, that's a lot trickier. The common fix, or maybe I should say workaround, is something called sticky sessions. This is where you tell the load balancer to always send a user back to the exact same server. It keeps their session data together, sure, but it creates this whole cascade of new problems. You get uneven load, the system becomes fragile, and even simple deployments become a huge risk.
And this really gets to the heart of the reliability problem. With sticky sessions, every single server becomes a potential single point of failure for all the users stuck to it. If that one machine goes down, boom, all of their sessions, their shopping carts, their progress, whatever, it's all gone. Instantly. So what's the modern solution? Simple. You externalize the state. You basically take all that important session data out of the application server and move it to its own, shared, super fast place, like Redis or a database. This is the game changer. It gives you the best of both worlds. Your application servers can stay stateless and scale to infinity, while the state itself is managed safely in one central place. Plus, this also opens up huge opportunities for better caching, which makes everything faster.
Okay, so now that we get the theory, when do you actually use one versus the other? Let's check out some real-world examples where each of these approaches really shines.
You're going to need a stateful approach when that ongoing conversation, that context, is the whole point of the app. I'm talking about things like a multiplayer game, where the server has to know where every player is at every millisecond. Or think about a Google Doc with multiple people editing at the same time. That's pure stateful.
And then there's stateless. Honestly, this is the default choice for most modern services, especially if you're building for scale. This is the world of REST APIs, the backbone of the web. It's authentication systems that use tokens, and simple things like a product search, where every single query is its own independent event.
But here's the real secret. Most complex real-world apps, they aren't just one or the other. They're a hybrid. Take an e-commerce site. When you're just browsing products, that's totally stateless. It's fast, it's scalable. But the moment you add something to your cart and start the checkout process, that part becomes stateful, using that externalized state we just talked about.
Okay, so Let's say you're working with an older, stateful app. You see all these benefits of scalability and you want in. How do you actually make that switch? Especially without, taking the whole thing down for maintenance.
Well, the basic game plan follows these 5 key steps. First, you've got to figure out exactly what your state even is. Then, you start to pull that data out of your application code, offloading it to an external service. Once you've done that, you can start scaling up your new stateless components and finish redesigning the architecture.
Now, for those really critical systems, the ones that absolutely cannot go down, there are even more advanced pro-level patterns. We're talking techniques like dual write, where you write to both the old and new systems at the same time, or event log replay, which lets you rebuild state in a new system from scratch. These allow for a perfectly smooth transition with zero downtime for your users.
So, look, if you take away just one thing from all this, make it this. For any modern app that needs to scale, you should always lean towards a stateless design. And for those times when you absolutely need to keep track of state, don't let your application server do it. Externalize it. Move it to a dedicated service that's built for the job.
And that really just leaves one final question for you to think about. As your own projects are growing, as you're facing new demands, take a good hard look at your architecture. Is it really ready to scale, or is it state holding it back? Thanks for joining me.